Now let's suppose there is this block resting on the floor and I exert some force on it. Okay, so initially I give a gentle push, let's suppose 1 Newton, and the block doesn't move. Then I apply some more force. Okay, let's suppose 2 Newtons. Still it doesn't move. Then I gradually increase the force, and at some value of force it begins to move. So what happens is there is some frictional force which is resisting the motion. Okay, and we can see the frictional force is changing, right? So let's suppose I exert a force of 1 Newton. Okay, the block doesn't move because there is equal and opposite force. Okay, 1 Newton of force opposing the exerted force, right? Then I increase the force to 2 Newtons. Then still the block doesn't move. Okay, so in this case the opposing force would be what? 2 Newtons. If it is less, what will happen? The block will move. Okay, block will accelerate. If it is more, then what will happen? The block will accelerate in opposite direction, right? So it is exactly equal to 2 Newtons. Now when I keep on increasing this force, so let's suppose at 10 Newtons the block begins to move. Okay, it begins to accelerate. So that means that means the maximum value of this frictional force is how much? It is 10 Newtons, right? So at 10
Yes, sir.
Newtons it begins to move. That means the maximum value of the opposing frictional force is 10 Newtons. Okay, so from this we come to know that there is a frictional force, okay, which we call static frictional force. It is the static frictional force. Why static? Because the block has not moved yet. Okay, so whenever we try to slide one body on the other body, okay, then there will be an opposing force acting between the surfaces of two bodies, and it is known as the frictional force, right? It is known as the frictional force. Okay, the static frictional force. So till the time the bodies don't slide, it is known as static frictional force. After one body begins to slide on the other body, there is still some friction. It is known as the kinetic frictional force. Okay, so from experience we know that static frictional force is more than the kinetic frictional force. All right, so now this static frictional force, it seems to be self-adjusting, right? So you increase the external force. So you start with very low value. Then what happens? The block doesn't move. That means the static frictional force is exactly equal to the applied force. You increase the applied force. Then what happens? Still block doesn't move. So you go from 1 Newton to 2 Newtons. Still it doesn't move. Okay, that means the static friction has increased to what? 2 Newtons. Then you increase it to 5 Newtons. Okay, the applied force. Then static frictional force becomes 5 Newtons. Right? So at some specific value of the applied force, the block begins to slide. That means there is a maximum value, a limiting value of static frictional force beyond which it cannot exceed. Okay? So static frictional force is self-adjusting self-adjusting force. That means it adjusts itself to the applied external force, but it cannot go beyond a specific limit. Okay, but there is a limit beyond which it cannot increase, beyond which it can't increase, and that limit is known as the limiting value or maximum value. We'll call it fs max. Okay, so now, all right, so when we see these two surfaces in contact with each other, the block and the floor, so they seem to be exactly flat. Okay, they seem to be exactly flat. But in reality, if you look into these surfaces through the microscope, okay, so here if I zoom it, still it will look flat. But if you look it using a microscope, you will see that there are some hills and dales, some irregularities between the surfaces. Okay, so this is the block. I have zoomed it using microscope, and this is what? This is the floor. So now what happens is the irregularities, okay, the hills and dales from the block, they get interlocked with the hills and dales of the floor. Okay, and that's why when you try to slide, a block on the floor, what happens? There will be a friction. Okay, there will be an opposing force. So since there is an interlocking, okay, you need some force to remove that interlocking. Okay, so when you push that block, what will happen? This surface will get distorted and it will move. So this is one reason. Okay, this is one reason. There is another reason. So another reason is, now this block and floor, okay, they are in contact with each other. So at the microscopic level, there are the molecules of these two surfaces in contact. Okay, so molecules of block and molecules of floor, they are in contact with each other. So if the distance between them, it's very small, okay, if it is under the range of what we say is molecular attraction, if that distance is very close, then the block and this floor, molecules of block and molecules of floor, they will not be able to distinguish. Okay, so molecules here, molecules of block which are in contact with molecules of floor, so for them these are like block molecules only. Okay, so there will be forces of attraction between these molecules and these molecules, so some temporary bondings are formed, some temporary bonds are formed. So when you push this block on the floor, what happens? You have to break these bonds. Okay, so as you push it, what happens? The bonds will get stretched. So there is a restoring force generated in the bonds, which will oppose the external applied force. But now it cannot go beyond some limit. So beyond some range, what will happen? If you separate the molecules beyond some limit, the bonds will break and the block will begin to move on the floor. Okay, so these are two reasons. One is the interlocking between the irregularities, okay, the hills and dales of the two surfaces, and another is the bonds, molecular bonds formed between two surfaces. Okay, so what are two reasons of friction? One is interlocking and another is molecular bonds. So is it clear? All right, so then let's move on to the laws of friction, laws of static friction. So now this limiting value of the static friction, which we are calling what? Fs max. Okay, the limiting value of the static friction, Fs max, is directly proportional to the normal reaction. Okay, it is directly proportional to what? Normal reaction. Now we know what is normal reaction. Normal reaction is the force exerted by the surface which is perpendicular to surface. Okay, if there is a body resting on a surface, the gravitational force will act downwards. So this is the case where the floor is horizontal. Okay, so gravitational force will act downwards, and due to which there is a force exerted by this block on the floor. There is an equal and opposite force exerted by floor on the block, which we call what? The normal reaction. Okay, which will act vertically upwards. Now this normal reaction is, this time it is exactly equal to what? The gravitational force which is acting downwards. Okay, I will not draw gravitational force. So this normal reaction is equal to what? The gravitational force which is acting downwards. Okay, but it will not be the case every time. Okay, so speciality of normal reaction is it is perpendicular to the surface. Okay, which is exerting that normal reaction, right? So in this case, this will be equal to what? The gravitational force. In other cases, we'll need to find it out, right? So what is normal reaction? It is the force exerted by the surface which is perpendicular to the surface. Okay, so the limiting value or the maximum value of static frictional force is directly proportional to the normal reaction. Then the limiting value of static frictional force, it does not depend on the area of contact. Okay, does not depend on apparent area of contact between two bodies, and this limiting value of the static frictional force depends on the nature of two surfaces in contact. Two surfaces in contact. And there is one more law that frictional force always opposes the sliding motion between two bodies. Okay, so its direction is opposite to what? The applied force, always. Okay, so these are the laws. So now see the second law, it does not depend on the apparent area of contact. So now let's suppose we have two bodies. So one is like this, one block is like this. Okay, the other block is like this. Both are wooden blocks, or let's suppose these are identical blocks. So one block is kept like this, the other block is kept like this, right? So now the maximum value of the static frictional force which is experienced by both of these blocks will be same. It doesn't depend on how much area of contact, how much area of this block is in contact with the floor. It doesn't depend on that. Okay, normal reaction is equal, then the limiting value of static frictional force will be equal, right? Then it depends on the nature of two surfaces in contact. So let's suppose you have taken one wooden block and another one is iron block. Okay, and weight of both of these blocks is suppose same, but the friction between wooden block and this floor and iron block and the floor will be different, right? So let's consider this block, and let's suppose you exert some external force on this block. Okay, so external force you exert in this direction. So this is F external. Now, what are the real forces acting on the block? There is one external force and there is one what? Gravitational force. Okay, the gravitational force is mg. These are the two forces, and now you can call them action forces. Okay, and there is reaction force due to this surface. So there is component of reaction force perpendicular to surface, which is known as the normal reaction. Okay, this component is known as normal reaction, and there is component of the reaction force due to the surface which is opposing this external force, and this component is parallel to the surface. So this is known as friction. This is known as static frictional force. Okay, so the component of force perpendicular to the surface is known as normal reaction. The component of reaction force, okay, or contact force you can say, parallel to the surface is known as static frictional force. Okay, and when the external force is equal to the limiting value, in that case this will be equal to what? Fs max. Okay, so now these two are the components of what? The contact force only. Okay, these two forces are because of the contact between these two bodies, the block and the floor, right? So contact force is neither perpendicular to the surface, is not parallel to the surface. It is at some angle, right? It will be at some angle, and we can find out that angle. Okay, so resultant of these two forces will be like this if we apply the parallelogram law. So this is, let's call it the reaction force R. Okay, and this angle theta, this is known as the angle of friction. Okay, so what is angle of friction? The angle between the total contact force, or let's call it the reaction force, and the normal reaction. Okay, so what is angle of friction? The angle between the net contact force, I am denoting it by R, and the normal reaction. Okay, is called angle of friction. This angle is known as angle of friction. Right. So now you can resolve this force into two components. So what will be N? It is equal to R cos theta. Okay. And what will be this Fs? Fs max, it will be R sin theta. Right. So now see here. So we talked about the frictional force. It is directly proportional to what? It is directly proportional to normal reaction. So there will be some constant. Okay, so here I can write, so Fs max is equal to some constant which is denoted by mu. Okay, mu s multiplied by normal reaction. So if I remove the proportionality sign and put an equality sign, a constant will come. So that constant is mu s. It is known as the coefficient of static friction. Okay, it is known as what? Coefficient of static friction. So now if you take tan of this angle, this is clear till this point?
Yes, sir.
Okay, so now this angle is known as what? Angle of friction, the angle between the total contact force and the normal reaction. Now N is equal to R cos theta and Fs max is equal to what? R sin theta. So now if you take the ratio of these two, okay, so ratio of these two, what do you get? So R sin theta divided by R cos theta will give you tan of theta is Fs max divided by normal reaction. And on left hand side, this R and R gets cancelled out. And on right hand side, what do you have? Fs max. What is Fx max? It is equal to mu s multiplied by the normal reaction. So you substitute that. So mu s multiplied by normal reaction divided by normal reaction. This normal reaction gets cancelled out. So you get tan theta equals to mu s, or mu s is equal to tan inverse of theta. Okay, tan theta equals to mu s. So mu s is equal to what? Tan of theta. And what is theta? Theta is the angle of friction. So is this thing clear? So next one that we are going to talk about is known as angle of repose. So there is a rotatable plank, let's suppose. So let me draw it. So this is the wooden plank. Okay, and I'm keeping a block on this plank. Now what I do is I move this plank, I rotate this plank. So what happens if I rotate it? Initially, for small angles, the block will not slide. So you rotate it gradually and gradually. At some angle, what will happen? The block will begin to slide over the plank. Okay, so that angle is known as angle of repose. That angle is known as what? The angle of repose. Right. So at some angle, what will happen? So this is your wooden plank. You are rotating it. Initially, it was kept horizontal. Now you have rotated it, and let's suppose at this angle, at this much angle with the horizontal, what happens? The block begins to slide. Okay, so this block begins to slide downwards. Okay, so what are all the forces acting on this block? So there will be one force due to gravity. It acts vertically downwards like this. Okay, so this angle is suppose theta. So this is force mg due to gravity, and there will be one force due to the
Normal
plank.
force.
Yeah, there will be a normal reaction, and there will be a frictional force. Okay, so normal reaction will act perpendiculars. It always acts perpendiculars. That's why it is known as normal reaction. Perpendiculars to this surface. So this is the normal reaction, and the block will slide like this down the incline. So what will be the direction of frictional force? Up the incline. Okay, so frictional force will act like this in this direction. So I will show it with black color only. Okay, so this is frictional force. Right. So I'm saying at this angle, what happens? It begins to slide. This block begins to slide. That means, so as you are increasing the inclination, this frictional force is increasing, and it has it has reached its maximum value at this angle. Beyond this value, it cannot increase. Right. So how much is this value? This is fx. Sorry, this is fs max. Okay, so this is normal reaction. Now what we can do is we can resolve this mg along two components. So one is this component called, it will be what? Mg cos theta or sin theta. So see, this angle is theta, so this will be 90 minus theta, and this angle is 90 degrees. So that means this angle will be theta. Okay,
Yes, sir.
right, Sanjay? This angle will be theta. How? This angle is theta. This is your right angle triangle. So this angle will be 90 minus theta. So since this is 90 minus theta and this is 90 degrees, this will be theta. Right? So this angle is theta. And component of mg through the angle. This is not mg, okay? This is mg. So component of mg through the angle is cos component. Right? So I will move this mg towards, sorry. This is mg. So this is mg cos theta, and this component will be mg sin theta. Okay, so now because block just begins to slide on this floor, on this plank. So what can I say? Mg sine theta will be just equal to the Fs max. Okay, Mg sine theta will be greater than or equal to. So I will say, because it just begins to slide, it is equal to the Fs max, and the normal reaction will be balanced by this component of mg cos theta, because there is no motion along this direction, right? There is no acceleration along this direction. So this force and this force are balanced. So mg cos theta is equal to the normal reaction. And now if you divide these two, what do you get? So once again you get tan of theta is equal to Fs can be written as what? Mu s multiplied by normal reaction. So this is mu s multiplied by normal reaction divided by, you have normal reaction. This thing gets cancelled out. So you have tan theta equals to mu s. Okay. So mu s is equal to tan inverse of theta. So this angle theta at which the block begins to slide, it is known as angle of repose or angle of sliding. Okay. So this is clear. And you can say it is equal to the angle of friction, because mu s is equal to tan theta. So this theta in this case is angle of friction, and here you can find mu s using this plank and block method. So you can rotate the plank and your block begins to move at some angle. That angle is known as angle of repose or angle of sliding. Okay, so this angle is equal to the angle of friction. But this case, in this case, it is known as what? Angle of repose, and this is the angle between the total contact force and the normal reaction. It is known as angle of friction. So you got this? Yes, no? Okay. So now I will redraw this diagram. Okay. So see, this is the plank. And now let's suppose this angle theta is greater than angle of repose. So what will happen? So if this angle is greater than angle of repose, the block will slide down the floor. Okay, the block will slide down the floor. Right. So once again, I can draw all the forces. So here, this force will be this force is the normal reaction. Okay, so this force we have already seen it. It is mg cos theta. This one is mu s multiplied by normal reaction. Okay, this is the static frictional force, Fs max. Okay, I will just write mu s multiplied by normal reaction, and the force in this direction. So what is force in this direction? It is mg sine theta, right? So now since there is no sliding, no acceleration in this direction, we can say always n is equal to mg cos theta. Okay, n is equal to what? Mg cos theta. So n is equal to mg cos theta, and then what will be Fs max? It is equal to mu s multiplied by normal reaction. So it is mu s multiplied by mg cos theta. Okay, and therefore net force along the floor. So what will be that? Now once it begins to slide, this right now it is static friction. Once it begins to slide, we'll call it kinetic friction. Okay, we'll call it what? Kinetic friction. So we'll just denote it by mu only. Okay, so net force along the floor, what will be that? Mg sine theta minus mu. I will just call this mu because when it slides, it will be kinetic friction. Okay, so it is mu times mg cos theta, right? This force minus this force. Yes, no? So mg
Yes,
sine
sir.
theta minus mu times mg cos theta. And this force is equal to mass times acceleration. This force is equal to mass times acceleration. So it is mg. I can take m common. Okay, g sine theta minus mu times g cos of theta. Okay, and you can cancel out m, and then you get formula for acceleration, which is g sine theta minus mu times g cos of theta. So if you have an inclined floor, an inclined plane, and there is some block or any object which slides down that inclined plane, then what will be its acceleration? What will be its acceleration? So its acceleration is g sine theta minus mu times g cos of theta. Yes, no?
Yes, sir. Understand, sir.
Yes, sir.
And this formula we have to remember, okay? We'll use it directly in the problems. Next, let's talk about the kinetic friction. So now, let's suppose our block is moving on the floor. Sorry. So let's suppose our block is moving on the floor with some velocity v. Now, still you need some force. You need some external force. Okay, you need to keep on exerting some external force to keep this block moving with that constant velocity v. But this force will be less than the limiting value of static frictional force. So now still there is some friction. Still there is some friction, but it is less than the static friction. So in this case it is known as the kinetic friction. Okay, in this case it is known as kinetic friction. And the only difference between static and kinetic friction is it is less than the static friction. Okay, otherwise all the other laws are same. So what were our laws? So laws of kinetic friction. So first one is mu, so limiting value of the kinetic friction, it can be written as mu k multiplied by normal reaction. So it is also directly proportional to normal reaction, but now the coefficient of friction will be less. Okay, so once the block begins to move, the coefficient of friction will decrease. Okay, so friction will decrease. Second thing, it also does not depend on area of contact. Okay, so fk max, so this is fk max, okay, maximum value. So fk max also does not depend on area of contact. It depends on the nature of two surfaces in contact, and fk max does not depend, it does not depend on this velocity. Okay, it does not depend with what velocity you are moving it, with what velocity you are sliding. The kinetic friction will be same. Okay, it does not depend on the velocity, right? And actually the kinetic friction will be same only. Okay, there is no minimum or maximum value. Once it begins to slide, there will be some friction, and that is the kinetic friction. Okay, so I'm writing max everywhere, but it is just kinetic friction. Okay, it does not depend on the velocity, and it depends fk, or we are calling it fk max. It depends on the nature of surfaces in contact. So these are the laws of kinetic friction, which are similar to the static friction. There is one addition, that this kinetic friction does not depend on the velocity. So provided the velocity is, it is under certain limit, which is known as the critical velocity. So are these laws clear, or is there any question?
No, sir. Yes, sir.
No, sir. Yes.
Okay. So then we'll see some problems. Before that, there is one more thing. So we know that the wheels are, they are circular. Okay. So why so? So in this case, for circular bodies, okay, so there is no sliding between circular objects and a floor. So circular objects roll, circular or spherical objects, they roll on the floor or the road. Okay. So in this case, now the area of contact, there is no area of contact. There is only one point of contact. Ideally, there is only one point of contact between this body and this body. So when this body moves, when spherical or circular object, okay, like a ring or a disc or a sphere, it will move on this surface, there will be no sliding. Okay, it will just roll, and velocity of point of contact is always zero. Velocity of the point of contact is always zero. Okay, so the center of this body will move with some velocity, but velocity of point of contact is always zero. So it is not sliding, and ideally therefore there will be no friction. But in practice there will be some friction, which is minimum. Okay, and that's why for any kind of motion, so where we want minimum friction, we use what? Circular wheels. Okay, or disc shaped wheels. Okay, or we use ball bearings, right? So that's the reason. So that is rolling friction. So rolling friction is negligible. So this point is clear. There is nothing in it,
Yes,
right?
sir.
Okay, Sanjay.
Yes, sir.
All right. So now we'll solve some problems based upon friction. A body of mass m is kept on rough horizontal surface. Coefficient of friction is mu. Horizontal force is applied on the body, but it does not move. Okay, so you are exerting some horizontal force, but it doesn't move. That means the horizontal force applied is less than the limiting value of friction. The resultant of normal reaction and frictional force acting on the object is given F, where F is. So this is very simple problem. It is from NEET, I guess 2019. Okay. So the resultant of normal reaction and the frictional force acting on the object is F. So our object is, let's suppose this is the object. So can you tell me which will be the answer?
Option B, sir.
Option B.
Yes, sir. Mu
No,
mg.
that is frictional force. This is not frictional force, okay? This is not frictional force. All right. So now you are exerting some external force and the block is not moving. That means the frictional force in this case, will it be limiting value of frictional force or will it be less than that? It will be slightly less, because if the external force is equal to limiting value of frictional force, the block will begin to move. Okay, so this is Fs. Fs is less than the limiting value of the static frictional force, which is mu s multiplied by, sorry, mu s multiplied by normal reaction. And normal reaction in this case is how much? It is mg, because the block is horizontal. So this is n, this is mg. Okay, so mg balances normal reaction. So this is equal to mu s multiplied by mg. This is frictional force. And the question is, what is the resultant of normal reaction and the frictional force? So it is resultant of Fs, the frictional force, and normal reaction. So it is total
Sir,
contact force.
option C.
Yes, option C is the answer. Good. Okay. So this is R. R is equal to what? Square root of Fs square plus n square. And since Fs is less than or equal to mu s multiplied by mg, okay, so this is equal to mu s mg, sorry, mu s mg square plus mg square, and mg you can take out. Okay, so it will be less than or equal to that, because Fs is less than or equal to mu s times mg. So option C is the answer. So which of the following statements is incorrect? Frictional force opposes the relative motion. Limiting value of static friction is directly proportional to normal reaction. Rolling friction is smaller than sliding friction. Coefficient of sliding friction has dimensions of length. Tell me. Option D. Right. Coefficient of sliding friction has dimensions of length. This is incorrect. It's true. Yeah, it is dimensionless. Good. So see, frictional force opposes the relative motion. This is true. Limiting value of static friction is directly proportional to the normal reaction. We know this. Rolling friction is smaller than sliding friction. Rolling friction is least of them. Okay, so this is also correct. So this one has to be incorrect. Okay, because all other three are correct. Coefficient of sliding friction has dimensions of length. We can see this. Okay, so friction is equal to mu times normal reaction. So this is a force, this is a force. Okay, so dimensions of force and normal reaction, frictional force and normal reaction are same. That means mu is dimensionless. Okay, all right. So let's see this question. A box of mass 2 kg is placed on the roof of car. The box would remain stationary until car attains maximum acceleration. Coefficient of static friction between the box and the roof of car is 0.2 and g equals to 10 meters per second square. The maximum acceleration of car for the box to remain stationary is. So alright, there is a box which is kept on a car. Okay, so let's suppose this is car. This car will accelerate. So now when this car accelerates, what will happen to the block, the box? It will tend to slide backwards. Okay, actually it remains there, and this car will move forward, right? Okay, so it seems like it is accelerating backwards, but this will happen only when there is no friction. Okay, if there is some friction, then what will happen? This external force, okay, external acceleration, it should be more than what? Should be more than the opposing frictional force. The external force should be more than the opposing frictional force. Okay, yes, no, right? So now, see, the frictional force we can find out. The coefficient of static friction is given. It is 0.2. Okay, so frictional force, maximum frictional force is mu s multiplied by normal reaction. So because this is horizontal surface, normal reaction is mg. So mu s multiplied by mg. Okay, and the external force should be greater than or equal to what? This frictional force. Okay, so we can say, so m multiplied by, so external force would be greater than or equal to Fs max. Okay, so that is m multiplied by a is greater than or equal to mu s multiplied by mg. So m and m gets cancelled out, and you can find out acceleration, which will be equal to mu s multiplied by g. What? Yeah, 2 meters per second square. Okay, so if acceleration is greater than or equal to 2 meters per second square, then this block will begin to slide. Okay, not before that. This is clear? Okay, simple question. Next one. A marble block of mass 2 kg is lying on ice when given velocity of 6 meters per second is stopped by friction in 10 seconds. Okay, so it is moving with velocity of 6 meters per second, but there is some frictional force. So there is some frictional force. So it stops in 10 seconds. Then the coefficient of friction is. Okay, so now we have to find out what will be deceleration due to this frictional force. Okay, so there will be some deceleration due to this frictional force. So we can find out that, so v square equals to u square plus 2 times, not this one, no, it stops in 10 seconds. Okay, so it stops in 10 seconds. That means v equals to u plus at we can use. We have time, we have initial velocity, final velocity is 0. Okay, so this is 0 is equal to 6 plus acceleration multiplied by 10. So how much would be acceleration? Acceleration is minus 0.6. Okay, take this 6 on other side. It will be minus 6. Minus 6 divided by 10. Minus 0.6 meters per second squared. This deceleration is because of what? The frictional force. Okay, so how much would be the frictional force? So the frictional force is equal to what? M multiplied by A. Let's take magnitude only. Okay, so it is 2 multiplied by 0.6 meters per second squared. Okay, and this is equal to what? Mu s multiplied by mg. Okay, so this 2 and m gets cancelled out, and you can take the g on the other side. So what do you get? 0.06. Okay, so 0.06 will be the answer. Got it or not? Okay, this will not be mu s. Let's keep it, let's call it mu only, because it is sliding, right? So it is 0.06. Sanjay, you got this or there is a doubt? Okay, so next question. A smooth block is released at rest on a 45-degree incline and then slides a distance d. It slides a distance d. The time taken to slide is n times as much to slide on a rough incline, okay, than on a smooth incline. So time taken on rough incline is n times than that of smooth incline. The coefficient of static friction is. Okay, so this is the question. So let's consider this is, sorry, so this is a rough incline, and so this is the block. So what will be the forces acting on it? What will be the acceleration? We had found the acceleration in this case is g sine theta minus mu multiplied by g cos of theta, right? Remember this. If there is friction, Okay, it is sliding. The acceleration will be g sine theta minus mu into g cos of theta. So let's call it AR. Okay, and if it is smooth incline, then there is only one force acting on it. That means there will be only one acceleration. And what will be that? It will be g sine theta only. So acceleration on smooth incline. Okay, so acceleration on the smooth incline is equal to g sine theta only. Now suppose it covers distance d on this incline and this incline. The time is different. Okay, and it is given. So distance d can be written as s is equal to ut plus half at square. We have the formula, right? If it begins to slide, initial velocity will be 0 and it has got some acceleration. Okay, different on different loads. Okay, so d is equal to, I can say, half of a multiplied by t square. So for rough incline, let's put it AR and TR. For smooth incline, it will be equal to half of AS, okay, TS square. So we can equate these two because they are, I mean, the block covers same distance on rough as well as smooth incline. So we can equate these two. So AR times TR square is equal to AS times TS square. And it is given that time taken to slide is n times on the rough incline than the smooth incline. So time on the rough incline is how much? It is n times that of the smooth incline. So this square is equal to as multiplied by ts square. So we can cancel out time on the smooth incline square on both sides. So here it will be n square. So acceleration on rough surface multiplied by n square is equal to acceleration on smooth surface. Okay, so this is what we got. And there we will put the values of acceleration, AR and AS. So let's add a page. Alright, so I got acceleration on rough surface multiplied by n square is equal to acceleration on smooth surface. So acceleration on rough surface is g sine theta minus mu multiplied by g to cos of theta, okay, multiplied by n square is equal to g sine theta, okay, and it is 45 degrees. So sine theta and cos theta is equal, right? So sine theta and cos theta is equal. So you can take 1 minus mu because this is 45 degrees. Okay, so g sine theta is also 1 upon root 2. Cos of 45 is also 1 upon root 2. So I will take it outside. So 1 minus mu multiplied by n square is equal to this thing, g sine theta. So g sine theta and g sine theta will get cancelled. Okay, so 1 minus mu multiplied by n square is equal to 1. So take n square on other side. 1 minus mu is equal to 1 upon n square. Then take mu on right hand side, this thing on left hand side. So you get mu equals to 1 minus 1 upon n square, or n square minus 1 upon n square. 1 minus 1 upon n square. This is the answer. Option C. Okay. A block of mass 2 kg is placed on the surface of a trolley of mass 20 kg, which is on smooth surface. The coefficient of friction between the block and the surface of trolley is 0.25. If the horizontal force of 2 Newton acts on the block, the acceleration of system in meters per second square is. Okay, so there is a block kept on a trolley. Okay, so this trolley, I'm drawing like this. Okay, so mass of block is m, is 2 kg. Mass of trolley, let's suppose it is capital M, it's 20 kg, and there is some coefficient of friction 0.25, and you are exerting horizontal force 2 sorry 2 Newton on the block. Okay, the acceleration of the system is, you are exerting a force on this block only and not on the trolley. So now you have to check whether this exerted force is greater than the limiting value of static frictional force, or if it is less than that. If it is greater, then what will happen? Only this block will move. Okay, because in this exerted force will exceed the frictional force. Okay, but now if it is less than the frictional force, what will happen? Then the friction will hold this block on the trolley. Okay, so block cannot move. That means the block as well as trolley will move. You got this? Yes, no? If it was floor, then nothing will move. But this trolley is also movable, right? The trolley is movable. Okay, so you have to check whether this block will slide on the trolley with if the external force is greater than frictional force, or it is less than frictional force. If it is less than frictional force, then what will happen? Both of them, they will be glued to each other, because external force is less than the frictional force. So got this or not? Okay, so let's check. Okay, so how much is the external force? It is 2 newtons. And how much is coefficient of friction? 0.25. Okay, so coefficient of friction is 0.25. How much will be weight of this? mg. Normal reaction is equal to mg. Okay, so limiting value of frictional force, Fs max, is equal to mu s multiplied by normal reaction. So mu s multiplied by mg. So mu s is 0.25 and n is equal to mg, which is 2 multiplied by 10. So 2 times 10 is 20. 20 multiplied by 0.25 is how much? 5. Right? Or 0.25 times 2 is 0.5. 0.5 times 10 is 5. Okay, so it is 5 Newton. Okay, and external force is how much? External force is 2 Newton only. So not enough to slide this block. Okay, not enough to slide this block. So what will happen? The block and this trolley, both of them will move with some acceleration. Okay, so this external force is equal to total mass of the system, which is m plus capital M multiplied by acceleration. So acceleration is equal to F divided by total mass, which is 22. 2 upon 22. It will be close to 0.1, 0.9, oh sorry, 0.09 will be the answer, right? All right. So this problem is, what is the maximum value of force F such that the block shown in the arrangement does not move? Okay. So the arrow of this force is not like this, it is like this. Okay, so force is acting slanting downwards on this block. So now we have to find out maximum value of this force such that this block does not move. Okay, so what will we do? We'll resolve the force along two components. So one horizontal component which will act like this, so which will try to move the block in horizontal direction towards right. Okay, and one vertical component which will be like this. So the horizontal component of this force, so this angle is 60 degrees. Okay, so since this angle is 60, this will be equal to 60 degrees. and therefore this is f cos of 60, right? The horizontal component is f cos 60, and the vertical component is f sin 60, right? And it is acting vertically downwards. So now, since this block is trying to this force is trying to move the block towards right, what will be the direction of frictional force? Frictional force will act towards left, right? So frictional force will act towards left, and since the block doesn't move, so frictional force is equal to what? It is Fs cos theta. Okay, Fs cos 60 degrees, right? The two forces are balanced, so block doesn't move. Okay, and we want to find out maximum value of this F. So that means this frictional force will be maximum. It is Fx max. Okay, so this is, so from here I can say that Fs max is equal to what? F cos 60, and we know what is Fs max. It is mu multiplied by normal reaction, so it is F cos 60. This is, let's call it equation 1, and then we have to find out the normal reaction. So that we can find out, okay, using the vertical equilibrium. So block is not moving, or it's not accelerating in vertical direction. That means total vertical forces are balanced. Okay, so what are the other forces? So there is gravitational force which is acting downwards. Okay, so if I look at this block, so there is gravitational force which is acting downwards, mg. This force F sin 60, it is also acting downwards. Okay, so it is also acting downwards, F sin 60, and the normal reaction due to the floor, normal reaction due to this floor will act upwards. So what can we say? That N is equal to, the total upward force is equal to total downward force. Okay, so force is balanced, and that's why I can say N is equal to what? F sin 60 plus mg. So let's substitute that here. So what do we get? Mu times F sin 60 plus mg is equal to F cos of 60. What is cos 60? 1 by 2. Okay, so this will be F by 2. Okay, how much is mu? Mu is 1 upon 2 root 3. It is F sin 60. What is sin 60? Root 3 by 2. So it is root 3 upon 2. And what is the mass? Mass is 3. Sorry, root 3. So root 3 multiplied by g is 10. Okay, so this 2 and this 2 gets cancelled. Then we can divide by root 3. So this root 3 and this root 3 will get cancelled. So we have f by 2 plus 10 on left hand side. So f by 2 plus 10 is equal to f. So if we move this f by 2 on right hand side, what do we get? 10 is equal to f minus f by 2, that is f by 2. Okay, and therefore f is equal to 20 newtons. This is the answer. Okay, so this is clear, or is there a question? A wooden block of mass 8 kg slides down an inclined plane of inclination 30 degrees to the horizontal with constant acceleration 0.4 meter per second square. The force of friction between the block and the inclined plane is. So there is a wooden block of mass 8 kg. It slides down an inclined plane. Okay, and inclination is 30 degrees. So this is your inclined plane. This is the wooden block. It slides down and with constant acceleration. So acceleration is given. So let's suppose A is acceleration. Now tell me, what is the acceleration? It is g sine theta minus mu multiplied by g cos theta. Yes, no? Okay, Sanjay, we saw this yesterday. Okay, so you have to remember this. When there is a block, okay, sliding down an inclined plane, what is its acceleration? The g sine theta minus mu multiplied by g cos of theta. We will not derive it again and again. We will just remember this formula. Okay, so this is given, it's 0.4, and then its mass is given, mass is okay. So inclination is given, that means theta is given. So the force of friction we have to find out. Okay, so from here we'll get value of mu, right? All right, so here we want to find out force of friction, right? So let's multiply this with what, m. Okay, or there is no need to find out mu also. If I multiply this with m, so this is what we will memorize. Okay, so m into a is equal to mg sine theta minus mu mg cos theta. Okay, so this is, what is this thing? This is force of friction, if you remember. So there are two forces acting on this block, okay, along that inclined plane. One is what, this component of the gravitational force mg sine theta, and the other force is what, the other force is the frictional force. It is mu multiplied by normal reaction, but it is negative okay, because it is acting in opposite direction, right? So this is the frictional force. Okay, this is the frictional force, right? So this is minus frictional force, Fs max. So this we can find out directly. Okay, and here mass is given, so it is m times a. Mass is 8 kg multiplied by acceleration is how much? 0.4. Now take this on left hand side. So what do you get? Fs max is equal to mg sine theta. It is 8 multiplied by 10 multiplied by sine of 30 is half, plus this 8 multiplied by zero point 0.4. How much is it? 3.2, right? So plus 3.2. Okay. So it is 40 plus 3.2. If you take this, yeah, sorry. There is sign mistake, no? This will be negative. I'm adding this. Okay. So 8 multiplied by zero point 0.4. Okay. It's 3.2. So if I take it on right, it will be negative. So it is 36.8, right? So next problem is a body of mass 100 grams sliding from an inclined plane of inclination 30 degrees. What is the frictional force if mu is equal to 0.7? This is again, this is similar to the last one. Okay, so there is a body of mass 100 grams. It is sliding from an inclined plane and we want to find out the frictional force. So again, we can write mu is given here, not similar to last one. This is easier than that. Okay, so what will be frictional force? Here it is uh, okay, so remember the acceleration formula, g sine theta minus mu into g cos of theta. So out of that, if you multiply this with m, you get this term as a frictional force. So how much is frictional force? It is mu mg cos of theta, right? So mu is 0.7 multiplied by mass is what, 100 grams, it is 0.1 kg, multiplied by g is 10 multiplied by cos of theta, theta is 30, so root 3 by 2. Okay, so 10 times 0.1 is 1 multiplied by 0.7. This is the answer, right? Option D is the answer. All right, next problem. So a smooth inclined plane is inclined at an angle theta with the horizontal. A body starts from rest and slides down the inclined surface. Then the time taken by the body to reach the bottom. So a body starts from here. We want to find out the time taken by that body, okay, to move till the bottom. So now This is smooth inclined plane. That means there will be no friction. So how much would be the acceleration? Good. G sine theta would be the acceleration. And it slides down this much length. Okay. So now we know the length. That means we know the displacement, right? And it is starting with initial velocity equal to 0. So s is equal to ut plus half at square, because we want to find out the time. Okay, so L is equal to ut, u is 0, plus half of at square, that is half of g sine theta multiplied by t square. So from here we'll get t. So let's take 2 and g sine theta on the other side. So t square is equal to 2 times L divided by g sine theta, and therefore t will be equal to square root of 2L divided by g sine theta. So is there such an option? Option C? No, but this sine theta is outside and there is no L. Okay, so there is no L. Here there is L, but this is not matching. That means we have to substitute for L. Okay, because other options are in terms of H. Okay, so what is sine theta here? H upon L, and therefore L is equal to H divided by sine theta. Okay, take this L on left hand side, sine theta on right hand side. So L is equal to H divided by sine theta. Substitute that. So substituting that, 2 divided by g sine theta, and L is H upon sine theta. So it will be sine theta square. Okay, for square root is sine theta, we can take it outside. Yeah, it is option C. So 1 upon sine theta multiplied by 2h upon g. This is the answer. Okay, good. A block of wood of 1 kg resting on an inclined plane of angle 30 degree just starts moving down. Okay, again an inclined plane. If the coefficient of friction is 0.2, its velocity after 5 seconds is. Okay, so now we have to find out the velocity. So what is acceleration? G sine theta minus mu multiplied by g cos of theta. Okay, and we want to find out velocity after 5 seconds. So v is equal to u plus at. U is 0, right? It is resting on an inclined plane. That means u is 0. Okay, so a is this, and t is equal to 5 seconds. So g sine theta minus mu g cos of theta multiplied by time is 5. Let's substitute values. G you can take out. It is sine theta, which is sine of 30, half, minus mu is 0.2 multiplied by cos of 30, root 3 upon 2 multiplied by 5. Okay, so it is 0.5, 10 multiplied by, this is 0.5. So this 0.2 and 2 gets cancelled. I mean 0.1 will be there. Root 3 is 1.73 multiplied by 0.1 is 0.17 minus 0.17 multiplied by 5, and this is 0.50 minus 0.17, so 0.33 multiplied by 10, 3.3 multiplied by 5. Okay, so all our calculations. 3.3 times 5, so 3 5s are 15, 15 plus 1.5, option B. Okay, so it is 16.5. Yeah, option B is the answer. Good. All right.